Well, hello again, everybody. This is Mr. Taylor talking about managing your money and planning your future. We're on lesson 16.2, example 1, where we will be comparing simple interest and compound interest. We've somewhat looked at this briefly in the last video, but we want to try and use an example this time so you could be a little clearer. You will compare simple and compound interest in a situation where no additional deposits are made. So this is a one-time thing that we're going to look at. We've talked about simple interest. We've talked about compound interest. But I also want you to make sure that we're clear about what we mean about annually. And the word annually, annual should mean yearly or one times a year. Maybe that'll help us out. Simple interest we know is a formula. Compound interest, simple interest, saying that we're going to take interest and we're just going to compound it on strictly we're going to just take the interest and not the principal. Compound interest say we're going to do both. So let's see what the author wants to do. Suppose you have two savings accounts, both with a principal of $100 and an interest rate of 5%. But one earns simple interest and one earns interest compounded annually. Which account will give you more interest after 10 years? Okay, let's jump right into it. Two accounts. One is PRT. The other is we're going to use a formula to raise interest to a certain power. So step one, if we're going to compare, and compare means to look and determine which is greater or which is less, in math terms, greater than or less than. That's what compare means. So here we want to find the amount of simple interest earned in 10 years. Remember the formula when we're looking at simple interest. Interest is principal times rate times time. So we have $100, which is the amount that they told us that we were doing, times 0.5%, that's 5% changed into a decimal, times 10. So when we do this, this is going to give us 100 times 0.5. Then of course we get 0.0005, and then we'll get 0.00, so we can just get rid of these zeros, add up, and we'll have $50 because we have to take consideration of these two decimals. So we'll have $50. So we know here that this is where they get the $50 from. Now this is what it says, that the account earns interest of $50. Okay, that's simple interest. So here we're talking about compounded annually in 10 years. So the formula is a little different. Instead of principal time rate time time, we're going to multiply the principal amount, which is $100, times 1 plus the interest rate, and we're going to raise it to a power. So I'm going to try and bring up my my little calculator right quick, and hopefully we could see what we're doing, how we have to do this raising. So we're looking at 100, and that 100 is times, and I'm going to put in parentheses 1 plus 0.05, and I'm going to close my parentheses, and I'm going to raise all of that to the 10th power. And that gives me $162.88, since we're talking about dollars. we round off in the hundred place, so we'll round this last 8 because the 9 is greater than 5. So we'll round it to $162.89. And then, of course, to find out how much interest, which is what they have, we just subtract minus $100, which is what we initially started with. And you see it gives us the $62.89. Okay. Let's move on to the next step. So it tells us to compare the interest earned in each account. So the account that earns interest compounded annually earns $62.89, which is $12.89 more than the $50 of interest earned with simple interest. How do we get that? We knew that we had 50, so we just take 62.89 minus 50, and that's going to give us $12.89. So that's the difference. Okay, so for the example we compared, we see that compound interest indeed earns the most money. Okay. So here's something I want you to contemplate for me. Melina saves $50 in an account earning 3.5% simple interest. How much more would her account earn in 10 years if her account earned interest compounded annually instead of simple interest? So what you're going to do is you're going to use your two formulas. You're going to use I is equal to principal times rate times time, which is simple, and then you're going to use A is equal to your principal amount times 1 plus the rate raised to the 10th power. So of course we know that this is going to be I is equal to 50. That's going to be 50 times 0.035 times 10, and then here we're going to look at A is equal to 50 times 1 plus 0.035 and all that raised to the 10th power. You can do this on your TI-CAS or if you're using a TI-84. So go ahead and stop it and use this information and see what you come up with. Okay, so I'm using a TI Nspire, and what I done is I see that my interest amount, my principal is 50. As you can see on my calculator, it is 50 times 0.035 times 10, and when I do that math, I'm going to get $17.50. Okay, that's how much simple interest that I earn. All right, so you want to keep that in mind, $17.50 simple interest over 10 years with the $50. Now, if I looked at compound interest, and I want to walk you through this with the Nspire if you're using it. So I want to add a calculator, home page, and add a calculator. And then what I've done is I took $50 times, that little raised dot is time, parentheses 1.0.035, that's my interest, 1 plus my interest, raised to the 10th power. Okay, this is going to give me a 1.4 something number, but anyway, once you multiply it, it does it according to PEMDAS, so it's going to add these two, that's going to give us 1.035, and then the calculator is going to raise it to the 10th power, and then it's going to multiply it times 50. So it does it in these steps, and we get $70 and roughly $70.53. So we can say that my interest here is $70.53. not my interest, but my total amount is $70.53. Well, what was my interest? If I look at my interest, then I will take my 70.53 and subtract that, and I will get an interest amount, which is $20.53. I got that by subtracting this minus 50, and that's going to give me the $20.53. Okay. So now we go back to what it says. So it says you want to subtract the principal of $50, and that's what we did to find. So we want to subtract the principal of $50 from what we just saw to find the interest earned of $20.53. The amount of earning interest compounding annually will be, well, let's see. Let's, how do I want to do this to make it a little clearer? So let's go back here and let's put $70.53. Let's put that there, if you don't mind. So let's put $70.53 here. So we subtract 50 from that. Yeah, let's go at $20.53. Compare the interest earned in each account, the amount. So let's see. No, I think what the author was wanting us to do here is let's do this completely different, because I'm trying to I really believe this is what I want you to what I want to see here. So if we looked at the actual subtract the principal of 50 to find the interest earned compounded annually. So let's go back and put 2053 here, and simple interest. Let's put what do we have for simple interest? Let me go back, if you don't mind, to see what that amount was. $17.50. So let's go ahead and put $17.50 here. And we want to compare the two. So if we compare the two, we're going to have 2053 minus 1750, and that's going to give us $3.03. So if we compare the interest, the amount that earns interest compounding annually earns 2053. So let's put $20.53, which is $3.03 more than the $17.50 of simple interest earned. And I believe that's the way we want to look at it as far as filling in these blanks. But we know mathematically, we know the difference is $3.03. So this should give us a conclusion that if we're compounding simple interest, which is good, but the more you compound, the more interest is compound, the more you will earn with no withdrawals. Again, this is Mr. Taylor. I appreciate you guys. Thanks for looking at this. And again, your comments are always welcome. If you need something a little bit better, more detail or whatever. But if not, if you haven't subscribed, then please do so. And I'll talk to you soon.